Okay, so when I was talking about, oops, when we were talking about rounding, when you're given math problems in your calculator, it might say 1.4725 or 0.837. When you are going through the whole problem, you're really supposed to leave that whole number in the calculator. So when you're in class, for class purposes, if for some reason you have a zero in the ones in the you have a zero in the ones place, so 0.235, you would round to the hundredths place. So if 0.235, 5 is in the thousandths place, 3 is in the hundredths, 2 is in the tenths. The 5 rounds up the 3 to a 4. So if your final answer was 0.235, it's okay to put 0.24. You would not want to put 0.2. This small of an amount, we have very small syringes. We can draw that up. So the expectation is you would do your best to draw up that amount. So, but for the purpose of calculating on a test, this is the answer that we would want to see. Now, if you're doing the math and you had 0.89, sometimes you're going to end with the hundredths place. You would leave it. You don't want to put 0.9, and you don't want to go further and put 1.0. Now, in a 1 ml syringe, you can draw up 0.9. It really, clinically, it depends on the medication, whether 1 ml would make a difference. Sometimes if it's a liquid antibiotic or it's something that has that very wide dose range, 1.0 mils is going to be fine. But when we're talking about anesthetics, potent sedatives, sometimes chemotherapy agents, I mean, there's not a lot of wiggle room. So you're going to do your best to draw up the exact amount. But for math purposes, you would want to leave that, if there is a 0 in front of the decimal, you want to leave it at the hundredths place, whatever it says. When you do your math and you have a number that's greater than 0 in the ones place, then you're going to round to the nearest tenth. So 1, so you have a 1 in the ones place. Then you have 0.445. You can round all the way to the ones. Now, the question here is the 5 would maybe make this 1.45. And then if you have a 5 here, would that make that 1.5? The best is to just look at this number in the hundredths place. So if I have 1.44, I'm not going 5, then making that a 5, then that making that a 5. The best way is to leave that 1.4. If you had 2.564, okay, 2.564, the 6 rounds the 5, and then that would be a 2.6. So again, if you have something in the ones place, 1, 2, 7, 8, 9 point something, you can round to the place closest to the decimal, which is the 10th place. Now, in various classes, you're going to be doing various math problems. I have you do math and anesthesia. You might, you're going to have more, you might have more pharmacology, Pharm 2, obviously it's going to be on every test. So we try to be consistent with that. And like I said, I alluded to in anesthesia, obviously there's going to be times when we round down and up, clinically, depending on the condition or depending on the medication. But I will address, like in anesthesia, I will address that in anesthesia. When you get into household systems, some medications are going to be measured on things that we think of in the house. So we're talking about like teaspoons, tablespoons, ounces. So when we get into, this would be like more when we get into the oral, over-the-counter medications. Sometimes we prescribe cough syrup. Sometimes we prescribe liquid medications like sucralfate, metronidazole liquid. So sometimes we will send them home and tell them to give a certain amount of teaspoons. But what we have to know, whoops, I don't know why that made a color there. What we have to know is what is the conversion. So 5 mils is going to be equal to 1 teaspoon. So for some reason, if it said in the medical chart, this patient received 1 teaspoon, usually we would want to write this patient received 5 mLs. Okay, so I've seen people write it both ways, kind of depends on the medication and the doctor. 15 mils is equal to a tablespoon. And then 30 mils is going to be equal to 1 fluid ounce. Okay, 1 ounce. Sometimes we get into GTT. GTT means drop. Let me just write that in here. And I guess it's written on the slide. I don't have to write it again. So if we pay, sometimes the doctor would write 1 QTT OSBID. That means 1 drop in the left eye twice a day. Now, normally we don't convert drop to something else. Drops are usually really pertaining to something that's in the eye. Sometimes we put drops on the skin, but most of the time we're speaking of the eye. Again, this is a little bit hard to measure. Most of the time, if we want to give I will tell you, we want to give a client 5 mils of a medication, we will send home usually a syringe with the owner. And then I usually show them where on the syringe. Certainly you may actually pour it, but usually you're not going to try to get a teaspoon and hold your dog's mouth open and try to like pour the spoon in the mouth. So it's much easier to use a syringe, and just as long as the client understands what they're giving and how much they're giving. One thing that this comes into play with, though, is sometimes owners are told to give peroxide. Sometimes if they can't get to the vet, if their dog ate chocolate, ate a pill, ingested something they weren't supposed to, hydrogen peroxide makes them vomit. Now, a lot of people will look up on the internet, they may call the clinic, and they may get those instructions to give the medication, to give the peroxide via a spoon or measure it out. So I would say sometimes clients will use, their little teaspoon measurement or tablespoon at home if they need to. The other thing is when we're talking about fractions, abbreviations, and when you guys look at the PowerPoint, there's notes underneath, but it's converting from one to the other. If we want to write 3 teaspoons, that equals so what I'm writing out here is 3 teaspoons. Usually the lower T is teaspoon, the capital T is for tablespoon. So lowercase t versus uppercase T. But we've got 3 teaspoons because we know a teaspoon is 5 mils, okay? 5 times 3 is 15, right? 15 mils. We know that 1 ounce is 30 mils, so half of that is 15. So 3 teaspoons is equivalent to a half an ounce, and if you write it half, or 0.5 ounces. Okay. When we get into converting household measures, now little charts like this are important. Again, most of these charts are in your Plum book. I mean, you can find a lot of these online, probably also in your pharmacology book. A lot of the appendixes have these converting. So these are the conversions that we need to know. A lot of times when we get into teaspoons, sometimes they will convert that into ounces. Let's get into ounces for a second. Now we deal a lot, obviously, in kilograms to pounds. That is one conversion. In that video, they were talking about having to know certain conversions off the top of your head, and then obviously there's conversions we don't do a lot that we might have to look up. But one that you have to know is 1 kilogram is equivalent to 2.2 pounds. And what's important there is because a lot of medications are either written in how they want to give milligrams per kilogram or sometimes milligrams per pound. So one of the first things I do when we immediately get a patient that comes in is most of our scales weigh in pounds. Now our scales at VCA, you could change it from kilograms to pounds. I'm old school. I weigh them in pounds. I divide it by 2.2, and then right on the chart, I put the weight in pounds and kilograms. So if my doctor gives me a list of medications, I know right off the bat if I'm using pounds or I'm using kilograms. And in anesthesia, I would say it's half and half. Some of our drugs are mg per kg, some are mg per pound. So it's just burned in the brain how to do that conversion factor. The other thing is kilograms always is less than pounds. So a patient that's 40 pounds is roughly 20 kilograms. Okay, it's kind of like dividing by 2. So if for some reason you were doing math and on your paper your kilograms is more than your pounds, you've gone the wrong way. You've multiplied. So kilograms are always less than pounds. Okay. I'm really not going to stress here, this is household lengths. We don't deal a lot much, or we don't deal with it much in pharmacology lengths. I'm going to focus mostly on volume and weight. Now the apothecary system is interesting because it's more of a liquid measurement system. And now there's different things on here. A minim is the liquid volume of a drop from a standard medicine dropper. I can tell you in my life, I've never used the word minim, ever, not till I studied for this lecture. One thing that we do talk about, we're going to talk about grains, because some medications come in grains, and I'll talk for a minute about drams. So let's go to this picture. One conversion also to know is 1 grain, GR is grain, not gram, it stands for grain. 1 grain is equal to 65 milligrams. I've seen people write 60, 64 point. It's actually, we just say 65, okay? So if you look at this picture, this box of aspirin tablets, say they are 5 grain tablets. If you multiply 5 times 65, each of those aspirins are 325 milligram tablets. So right off the bat, that tells you, because 1 grain is equal to 65, but there's 5 grains in each tablet. So you got to multiply 5 times 65. And again, the standard aspirin is about 325 milligrams, a standard adult. Now, this aspirin right here is low dose. Low dose, this says on the label 81 milligrams, so it does list this in the milligrams. But one tablet that we use a lot of is phenobarbital. It's an anti-seizure medication. So a lot of dogs that have seizures are on phenobarb, sometimes typically for life. And it is listed in grains. You can see that this is a half a grain tablet. So half of 65, I'm literally going to do the math because I like to make sure it works out. Let's see. What did I just say? 65 divided by 2, 32.5. So that says 32.4. So phenobarb tablets come in quarter grain, half grain, and grain. So they come in different strengths. Now, when I was talking about dram, a lot of times that's how they measure these dispensing containers. So again, they will give you 1 ounce equals 8 drams. The only time DRAM comes into play is a lot of times as the technician, you are in charge of ordering new bottles. Sometimes you need these little, this has a little, it says an orifice reducer. What that does is it doesn't allow all of that to come out. It has the tiny, people that do essential oils, they typically come in these little bottles, so they don't let out all the oil, they just let out drops. But here's a 2 DRAM vial. All of these pharmacy containers are sized in drams. Other than that, I don't use that term a lot, only when we're like restocking the pharmacy or reordering. And we usually order a variety of sizes. You know, we usually have some bottles so we can dispense liquids or, you know, capsules, sometimes powders. So you come in these different containers. The main one on here that I want you to know is grain, dram, ounce, pint, quart, gallon. So I guess there's only, I guess not really, the minimum is not as important. Probably not even dram. I don't know why it keeps, whoa, writing on the screen. So we will, Mrs. Gillis, she had sent me some pictures because she had some math charts that she had, and she took pictures of some of her math charts, and she's got a nice one that goes over gallon and quart and pint. And there's a lot of mnemonics about that, figuring out obviously gallon is bigger than an ounce. So go from there. Now, in that video that you did the homework on, I have to go through that too, I will be grading that, is the conversion systems within a system. So if you're gonna, it's usually within a conversion system, you're either gonna be multiplying or dividing to go one way or the other, because you have to be able to convert with another unit of measure. So for example, if we're in the grams, converting from grams to milligrams, or if we're in the liters, converting from milliliters into liters. So if we talk about it, what's known as a conversion factor always has a value of 1. So if, you know, when we start in the middle there, and we're gonna say, you know, there's 1 gram, you're either gonna go up or down from that 1 gram. So if you're gonna change grams, you're either gonna multiply or divide to go in one of the directions. That was like that stair picture, the stair going up or the stairs going down. To convert from a bigger unit to smaller, you're actually going to multiply the conversion factor. And if you want to go from a smaller unit to a larger one, you would divide from that, okay? For example, if we're going to talk about, and it doesn't pop up on this screen, but if you want to go from 1 liter and we're going to convert it to milliliters, you would multiply 1 by 1,000 because there's 1,000 milliliters in a liter. So if someone wants to know what's the equivalency, or how do we convert, 1 liter is equal to 1,000 milliliters. 1 gram is equal to 1,000 milligrams. And that's just, those are common ones that we use quite a bit. Let me get to here. So this is an area, and a lot of people do math differently. So I've never said anyone has to do it exactly how I do it, how you do it. If we get the right answer, that's what's most important. If you've, and I don't know if this is what Mr. Williams has done with you, but dimensional analysis is you have to first know the conversion factors. And those are like the charts that tells you 1 ml is this, 2 teaspoons is this, or 1 teaspoon is this. So you know what you're converting it to. Then this is where you put the problem out there, and then you cancel things out. So typically what you want to be measured, or what you don't know, or what your desired unit is what goes on top of the conversion factor. So if we have like one here, we want to we have 1.5 grams. We want to know how many milligrams is that. So the unknown is how many milligrams. We don't know how many milligrams are in there. That's what we want to find out. But we have to know what is the conversion. The conversion factor is there's 1,000 milligrams in 1 gram. But the problem is we have 1.5 grams. We don't, if we had 1 gram, it'd be super easy. We have 1.5. So how do we get to milligrams? So the first thing we do is you list in this form what you know. I know, and remember what you want is on top, okay? I know 1,000 milligrams is in 1 gram. In the video, they showed you could write it either way. Typically, the reason the milligrams in this example is on top is because we want to know milligrams. So most of the time people will write the unit that they want to know, that value on, you want milligrams on the top. So if I know there's 1 gram is 1,000 milligrams, then this is going to be blank and I can figure it out. So if we basically go here, you have, and it's not on here, this is actually where I should get my board out here. Let me write it on here real quick, and then I can try to show you. I bought this board just for this class. So you have 1,000 milligrams, and we have that over 1 gram. And then we have our unknown grams. So hopefully you can see that. So there's a glare. This is where technology and boards is going to be stupid. Okay, so I have 1,000 milligrams over 1 gram. I don't know how many milligrams I have, but I know I have 1.5 grams. So then what you're going to do is, this is what we do, is we cancel out what we know. Okay, 1 times 1,000 times 1.5 . I don't know. Oh, the glare is terrible. I apologize. But what you have here is we canceled out the grams, and then that basically gives us 1.5 times 1,000, which equals 1,500. So there's 1,500 milligrams in 1.5 grams. Now, some people prefer to do the write it out via these dimensional analysis. Oops.
What was above the 1.5 grams that you put on the whiteboard?
The bottom?
No, the top, like above what?
Oh, it was a blank. It said it was blank. It was blank milligrams over 1,000 or 1.5 grams.
Okay, and then what did that you multiplied 1,000 times 1.5?
Yeah.
And what'd you get?
1,500.
Okay.
So the other thing, if you open these notes in Edit View, when you view the PowerPoint, it shows you underneath in the notes page a couple ways to do it. There's ways to lay it out like a straight, almost algebra problem, and then there's a way to put the boxes over each other. Let's look at the next slide. Okay, so here are some examples of how to set up these conversion factors. Okay, you have 500 mils of a solution here, okay? But we want to know how many liters that is, okay? So right now you have 500 mils, and then we have 1 liter is equal to 1,000 mils. They have liter on top because they want to know how many liters. So what happens here is you would cross off your mils, 500 divided by 1,000, because what happens is you get 500 over 1,000. You have to reduce that fraction, okay? So, I mean, 500 comes out to be 0.5. And this one, you have 5 kilograms, but we want to know how many grams that is. Well, we know that now 1,000 is on the top because we want to know grams. So you have 1,000 grams is 1 kilogram, but we have 5 kilograms. So what you do here is you cross off those kilograms, okay? And then you're going to multiply across, and you're going to multiply 5 because kilograms cross each other out. And you're going to multiply 5 times 1,000. That gives you 5,000 grams over 1, which equals 5,000. So there's 5,000 grams in 5 kilograms. Let's look at this one. The third one here is 3.5 liters is how many mLs? So we have mLs on top of our conversion factor because that's what we want to know. There is 1,000 mLs in 1 liter, but we have 3.5 liters. So if we cross off our liters there and you multiply across, you have 3.5 times 1,000, and then you would have that over 1. Well, 3,500 over 1 is 3,500 mils. Let's look at one here at the bottom. 800 grams is how many kilograms? So we know that 1, and we want kilograms on top because that's what we want to know. So I have 1 kilogram is equal to 1,000 grams. You have 800 grams. So what you're going to do here, cross off your G's, okay, and multiply across. That's going to give you 800 over 1,000. Now this is one that you have to divide. 800 divided by 1,000 is going to give you 0.8 kilograms. So these right here is ways to do it in a dimensional analysis. But of course, there is a shortcut method. If you are going from kilograms to grams, you just move the decimal point 3 places to the right. If you are going grams to kilograms, you move the decimal point 3 places to the left. Liters to mils, 3 to the right. Mils to liters, 3 to the left. So maybe I'll just write it on this piece of paper rather than use my big board. So if I have 10 milligrams and I want to know grams, okay, there are less grams than there are milligrams. I'm going to go to the left. So a 10 is 10.0. If I go 3 to the left, 1, 2, 3, maybe that's better than on paper. So I have 10 milligrams, I want to know how many grams. Going from milligrams to grams is we're going to the left. So 10, sorry, that's super messy. 10 is really 10.0. So I take a decimal at the end of the 10 and I go backwards. 1, 2, 3. So I had to put a 0 here, It's 0.010. So that's the shortcut method. Rather than listing that whole, the dimensional analysis and writing it like a fraction problem, you can also just move the decimal. If you had, let's say you had 4.5 milligrams and you wanted to know grams. Okay, you have 4.5 and you're going to go 1, 2, 3. Okay, so if I had 4.5 milligrams and I want to go to grams, okay, it's going to be 3 to the left. So here's 4.5. I have the decimal. I go 1, 2, 3. Or 1, 2, 3. So that's 0.0045 grams. It's basically dividing by 1,000. 3, gosh, I can't keep this lid. Where did it go? Oh, well. Shoot, I'll find it. Okay. Before we get into temperature, I think I want to stop with that. My plan is to, she sent me pictures of those math charts that she had, so I was going to just put it in like a little PowerPoint and send that to you later, because I think that might help with the math too, help with the homework. Also, that video channel, the one I sent you the other day, she's got some good videos on math and your math book. Are there any questions?
What was the liters to milliliters? You moved decimal to how many places? I think it was to the right or something.
To the right.
Okay.
Because 1 liter is 1,000 milliliters, so it's getting bigger.
Okay.
It's funny because a liter of fluids is big, and inside there is 1,000 milliliters. So that when you're going to the right. Now kilograms is bigger, so you're having more kilograms than you are grams. If you end up working with exotics, you work a lot in grams because they're little. So we usually weigh them on a gram scale. We have a little scale for like little mouse or guinea pig. So if you end up doing exotics, you'd work a lot more with that kind of system.
And what's the difference between liter to milliliters and milliliters to liters?
So the standard unit of measure of volume is 1 liter. So everything is based on a liter. And then you're either going bigger or smaller. So a milliliter is technically, there's 1,000 milliliters in 1 liter.
Mm-hmm.
So what you're going to do is you're going to end up, so I just put it back on the screen. So a liter to milliliters, you're going to go 3 to the right because you're going up in number. If you have a milliliters and you want to know liters, then you're going to move it to the right. I'm sorry, to the left, because you're going to go down in number.
Okay.
But you always have a standard measure: 1 gram, 1 liter, 1 meter. Those are your middle, like your ones. And then you're either going to go up or down based on what unit of measure you're converting to.
Okay.
If anyone that's on here that doesn't have more questions, you're free to bop off and have a good weekend, as long as you've typed here in the chat. If people have a few more questions and they want to hang on, feel free.